Today you're going to start Chapter 4. In Section 1, you'll examine several similar shapes to determine how those shapes are related. You will use the patterns that you identify to find missing lengths and areas on the shapes to make scale drawings. In Section 4.2, it introduces the idea of proportional relationships through tables, graphs, equations, and real-life situations. You will learn strategies for solving proportional situations. And in the last section, Section 3, you will be introduced to algebra tiles. You will use their areas and perimeters to build expressions and combine like terms. You will work with algebra expressions, simplifying and evaluating them for given values. Today we're going to take a look at 4.1.1. Are the figures the same shape? Today you will extend your study of ratios by looking at enlargements and reductions of geometric figures. Think of a copy machine and what it does to a picture when the enlargement button is selected. The machine makes every length of the picture larger or smaller by multiplying it by the same number called a multiplier. That multiplier is also called the scale factor. Multiplier and scale factor are important vocabulary terms. So let's take a look at question 1. Karen is learning how to use the copy machine at her school's main office, and she decides to scale the figure shown at the right by 300%. She wonders what will happen to the figure. Note, for all problems, the original size dot paper in the enlargement or reduction is kept the same so that you may compare the sizes of the figures. So let's take a look at this. If we're going to look at this shape and we're going to enlarge it by 300%, that means we're going to take each side of the shape and multiply it by 3. Alright, so let's take a look at this bottom side. It is 2 units across the bottom, so we're going to redraw it by taking 2 and multiplying it by 3. That would be enlarging it by 300%. So our new shape will be 6 units across the bottom. And then we're going to do the same thing with the other side lengths. So if I go up, it's going to be 1 unit on the original, but 300 times that would be 3 units. And then going across is another 2. So we're going to go across 6. And then up times, that's 1, so times 3 would be up 3. And then across is another 1, so that 1 times 3 is 3. Remember, it's not 3 dots, it's 3 spaces. So here it was 1, 2, 3 spaces. All right, and then we're going down now, and that's a space of 1 right now, so we're going to make it 3. And then the slant side's kind of hard to do, so we're just going to connect the dots. So our new shape looks like this. Alright, so if we take any pair of corresponding sides being those which are the same on the shape after the enlargement. So we take this bottom side and the bottom side here, and we look at the ratio of them. So we're going to always write our ratio as copy over the original. So the copy is the larger shape in this case, and this side is 6. And we look at the smaller side on the other shape, and it's 2. What do we know about 6 over 2? Well, hopefully you're saying that that equals 3, and that's why the new shape is 300 times the original shape. I can take any pair of sides and do that same thing with them. So if I take this side up here, that's 3, and on the original shape it was 1. And if we write the ratio of copy over the original, we get 3. Let's take a look at a new one. Alright, so here's the new shape, and it says Karen wants to try scaling the figure shown at the right by 50%. What do you think will happen? Alright, well 50% is less than 100%, so hopefully you're saying in your mind it's going to make it smaller. So let's go ahead and reduce the side lengths. If this side was 2, it's now going to be half of that, 50% of that, which makes it 1. So I'm not going to be able to redraw the shape on here. But the new side would be 1, and the original was 2. So the ratio would be 2 over 1. Let's look at the next side. This side has the side length of 4 right now. And if I would reduce that by 50%, I would get a new side length of 2, which would mean my ratio is 2 over 4. So I just realized I made a mistake in this last one, and this is a very common error, that this 2 over 1 is not written the right way. Because we're going from a larger shape to a smaller shape, our scale factor should be a fraction that's lower than 100% or 1 whole. So it's really 1/2. So this 2 over 1 is not correct. So let's take a look at another side length. Let's take a look at the top. It's 2 across, and on the new shape it would only be 1 across, which would also make it a ratio of 1 over 2. Let's take a look at the toolkit entry next. Alright, so here I have the toolkit entry on similarity and scale factor. It says two figures are similar if they have the same shape, but not necessarily the same size. In similar figures, the length of all corresponding pairs of sides have the same ratio. I'm going to highlight that. In similar figures, the length of all corresponding pairs of sides have the same ratio, and their measures, corresponding angles, are equal. That's important to know. A scale factor compares the sizes of two parts of a scale drawing of an object with the actual sizes of the corresponding parts of the object itself. The scale factor in similar figures is simplified ratio of any corresponding sides. I'm going to highlight that. The scale factor in similar figures is the simplified ratio of any pair of corresponding sides. So now let's take a look at these shapes. So if I take a look at these shapes and I find the corresponding sides, 40 corresponds with 16. Those are the same sides on this triangle that was either enlarged or reduced. We're going to say it was enlarged. We're going to say that the first shape was the smaller one and that we went this way with the enlargement. So then another pair of corresponding sides would be this 10 and this 25. And the last pair would be 18 and 45. So to the left, you can see they wrote these corresponding sides as ratios, and they actually went as copy over the original, so they're saying that the smaller shape was the copy, but it doesn't matter unless I tell you that one is the copy and one is the original. So in this case, they're saying that 16 was the copy and 40 was the original. So they wrote it as 16 over 40, and that reduces to 2/5. The second pair of sides, they have 10 over 25, and that reduces to 2/5 as well. And the last pair is 18 over 45, that also reduces to 2/5. So notice that the ratio of the corresponding sides is the same for all three pairs of sides, which means my scale factor, or my multiplier, was 2/5. So I didn't actually go from the larger one to the smaller one, or I actually went from the larger one to the smaller one, the reverse of what I was saying at the beginning.